Today, me and my teammate will talk about our mini project. So our mini project name is Smart Grid Monitoring System. So without further ado, we will first introduce ourselves. So I will start first. My name is Muhammad Hadrami bin Muhammad Anwar. My ID number is 512201220046. I am Bachelor Engineering Technology Electrical Engineering student. Daniel, can you introduce yourself?
My name is Muhammad Denifan bin Afian. So my numbers ID for my student ID is 5122022310 and my course is Bachelor of Electrical Technology.
Okay, thank you. So can you tell us about our introduction project?
Alright, okay. And for our introduction, our project, technology plays a crucial role in various industries, including the energy sector, where advancements have been significant. With the increasing demand for energy efficiency, the integration of IoT-based technology has become essential, particularly in the development of the smart grid monitoring system. This system leverages IoT capabilities to revolutionize energy management, offering real-time data and collection for insightful analysis.
Okay, thank you
So,
for.
so our project background is to create a smart electricity monitoring system using ESP32, which will display the reading from the sensor on the display and cloud from PingSpeed. Okay, this is our project motivation and objective from our project. So motivation, addressing using frustration and with electricity meters, lack of understanding, handling energy efficiency awareness. Our objective is develop user-friendly smart grid monitoring system, ensuring compatibility for domestic and commercial use. And to main focus area, we enhancing user experience with energy consumption data, promoting energy efficiency awareness through environmental insights.
Okay, thank you, Daniel. So I will go through our problem statement. So the challenges we face today is the energy landscape. As we know, we although we have like better grid technology nowadays, we also have problem with implementing it because sometimes we will go through like uninhabited places to put the stuff. It's not a good location to put the stuff, for example. And then lack of efficient energy management system. As you know, nowadays, even though the energy efficiency system is way better than before, it still one reach nearly 90% for most system. uh most of the energy we produce, some of it just go to waste. For example, like it just become heat or just become sound energy. And lastly is the impact on household practices and grid operation. So because our system is focusing on both domestic and commercial uses, so the impact on household practices is basically uh, the way that household can use this. How people in the house usually don't care about energy efficiency. And grid operation, for example, is basically grid grid system that is already too old usually is less efficient. So next, for the item needed is, so first of all we need the sensor, which is ZMTP101B, and then we need SCT013, and then BME280, and we also need the microprocessor, which is ESP32, and we also need two OLED screen. Okay, so from the block diagram, we can see that for the sensor will be our input, which is SCT013, will be our current sensor. And then our voltage sensor will be the ZMPT 101B, which is our voltage sensor. And then to read our temperature, humidity, and pressure will be BME2X0. And then all of those data will go through microcontroller, and then the output will be the two OLED screen. One of the OLED screen will show the temperature, humidity, pressure, and the condition, and the other one will show the voltage, current, power, and also electrical usage. And then all of the data except the condition will be sent to ThinkSpeak. Okay. So next, this is our wiring schematic. As you can see, the BME2X0 and the OLED and the first OLED screen will share the same pin. For the ground and VCC pin, there's no problem. But the reason why it can share SDA and SCL pin is because both of the component have different addresses. And then for the SCT, there's a wiring need to do. So two of these are 10K ohm, and one of it is 100 ohm. And then it's connected to the capacitor and go to ground. Other than that, the voltage sensor, the MPT101B, is the most basic one here. It's the easiest to install. So from the schematic, we can see that although it look complicated, it's actually really easy to install. However, be careful that because if we install it wrong, there's a chance that the component could be broken. So from flowchart, we can see when it first started, it will try to connect to Wi-Fi. So if it failed to connect to Wi-Fi, it will directly end the program with error. If it's connected to Wi-Fi, it will directly go to the tree sensor. So all three sensor will work semi-dependently. So BME2X0 will work independently, and then ZMPT and SCT will work semi-independently, because the BME2X0 is only to show the humidity, pressure, and the temperature. It has nothing to do. It doesn't go through together with the current and voltage sensor. So for the current and voltage sensor, we will use it to calculate the watt and then calculate the usage. And then we will show the voltage, the current, and the power, and also the usage to the OLED screen too. And then we will send the data to ThinkSpeak. After we send the data to terminal, and then from the terminal, we will send it to ThinkSpeak. And from the ThinkSpeak, it will show our voltage graph, current graph, power graph, and usage. And also for the BME2X0, the pressure will directly go to terminal and then ThinkSpeak. However, the temperature, humidity, uh, there's a case for it. It has to go through this case. So, for example, if the temperature is lower or equal to 35 Celsius, the humidity is lower or equal to 60%, then it will be cool or dry. So this will be shown on OLED screen 1. It will not be sent to ThinkSpeak. So the next one is, so this is our project prototype. As you can see, we use two OLED screen here, and then this is the light. Because it's too bright, I have to cover it with a box. And this is our current sensor, and this is our voltage sensor. So the live wire and the neutral wire have to go through the voltage sensor first for it to read the voltage. And then this is our ThinkSpeak result. So as you can see from our ThinkSpeed result, the temperature, we have tested this for like multiple hours, like 3 to 5 hours. As you can see, this is the result as we get. Like the pressure was going down at this moment, and the humidity was around 40%, and the temperature was around 30%. And the voltage, the current, and the watt is have a there's a consistent because we only test one unit, and it's good that electricity is consistent, because if it's go up and down, that's mean there's problem with the grid, right? And then this is our electrical usage. As you can see, although it was consistent, and then there's a jump. This is because like electrical usage over couple hours it will jump, because it is electrical usage. Over time it will increases, right? And then this is our OLED result. As you can see, the temperature, the humidity, and pressure, and also the condition is shown on the first OLED. And then the second OLED shows the voltage, the current, the power, and also the usage. As you can see, the usage, because we tested on a LED lamp, the usage is so small that we have to make it in 6 significant figures for it to even show us on the screen. Otherwise, it will be 0.00. So next, for the conclusion, can you do this for me, Daniel?
Yeah, alright. Conclusion from our project, yeah, that we can conclude is Smart Green Monitoring System offers a user-friendly solution for electricity monitoring, catering to both domestic and commercial users. It easy setup and initiative interface make it accessible to all, while its integration of sensors and microcontrollers enables real-time data processing and remote monitoring. With its potential for scientific usage and future enhancement, this system holds promise for enhancing energy efficiency and contributing to a better future. That's all from us. Thank you.
Okay, thank you. That's all from us. I hope you find this helpful, and goodbye.